Welcome to the Lighting Controls Association's webinar on plug load control. My name is Craig DiLouie, Education Director for the Lighting Controls Association. This presentation is based on a new course in our Education Express online distance education program. It introduces you to automatic plug load controls, a simple but powerful opportunity to generate substantial energy savings in commercial buildings. You're going to learn about the utility and potential energy savings of plug load control, how to implement this control strategy in energy code compliant new construction as well as existing buildings, how to implement appropriate strategies for plug load control based on the application characteristics, and how to select the right equipment to implement these strategies as an extension of the lighting control system. Specifically, over the next few minutes, we'll take a look at the rationale behind plug load control, various codes and incentives that either require or incentivize this energy saving approach, strategies and the types of equipment used to implement it, and how to get started on decision making. First, let's talk basics. What are plug loads and what are the benefits of automatically controlling them? A plug load is equipment powered by plugging into an ordinary AC receptacle. Plug loads such as computer monitors, task lighting, coffee makers, and vending machines are common in many buildings, especially office buildings where use is intensive. They are significant and the fastest growing load type in buildings, in some cases exceeding the lighting load. Because these devices often remain on when they're not being used or draw power in an off or standby state, they offer an attractive target for automatic removal from power to reduce energy consumption. By automatically disconnecting these devices from power when they're not being used, energy cost savings can range from 15 to 50%. Due to the effectiveness of this energy saving strategy, a growing number of commercial building energy codes now require automatic plug load control using the term automatic receptacle control. Controlling plug loads is a natural extension for lighting control, as the same strategies and devices used for automatic switching of lighting can be deployed for plug load control either at the receptacle or circuit level. Plug loads include computer monitors, printers, cell phone chargers, task lights, copiers, personal fans and heaters, AV equipment, and more, all of which can be switched off at night without negative consequences. A 2008 California study by L. Moorfield found that computers and monitors accounted for about 2/3 of plug load devices, with the remainder split between office electronics and miscellaneous devices such as task lights, telephones, and coffee makers. The researchers discovered that offices contained an average 30 plug load devices per 1,000 square feet, or 7 per office worker, combining to account for about 30% of total building electric energy consumption. Today's office equipment typically operates with a range of power levels or modes corresponding with user activity, though it is usually on at some level. In active mode, the user is operating the equipment, which at times can draw its maximum power. If standby mode is featured and enabled, the equipment will go idle after a period of no user activity but remain on at a lower power level. The equipment may power down to off or be manually turned off by the user. Even when the device is off, however, it may continue to draw a small amount of power while it's connected to a receptacle so as to start quickly. This is called a vampire, phantom, or parasitic load. According to the National Renewable Energy Laboratory, plug and process loads accounted for 40% of commercial building energy consumption in 2017, which will grow to roughly half of all energy consumption within 20 years. Another study by S. Pohl and C. Tubert in 2012 estimated plug loads at a maximum of 25% energy consumption in less efficient buildings and 50% or more in high efficiency buildings. Due to the size of these loads that are either used in relation to occupancy or on a predictable schedule, they're attractive targets for reducing energy consumption using automatic shutoff, long in use for control of general and task lighting, with the highest energy savings achievable in buildings where plug loads are intensive. In a 2012 study conducted by the U.S. General Services Administration as part of its Green Proving Ground program, the GSA evaluated automatic plug load control in 8 office buildings. A dozen standard power strips were replaced with advanced power strips controlling more than 295 devices, which were monitored over 3 test periods each month long. All workstation devices already had power management in effect. The advanced power strips de-energize the circuit based on a schedule, de-energize connected devices based on load sensing, or a combination of these strategies. Even with power management enabled, GSA recorded significant energy savings, 26% in workstations and nearly 50% in kitchens and printer rooms. The most successful control strategy was scheduling, which generated an average 48% energy savings. Highest savings were generated with devices operating 24/7, such as printers, copiers, and kitchen appliances. Due to the substantial energy savings that can be gained by controlling plug loads, a growing number of energy codes and utility incentives either require or incentivize their installation. In new construction and major alterations, permanently installed plug load controls are required by commercial building energy codes based on the ANSI ASHRAE IES 90.1 energy standard, as well as California's Title 24 Part 6 energy code. Additionally, some states, such as Florida and Washington, have amended their adoption of the International Energy Conservation Code, or IECC, to include plug load control. As of the 2018 version, the IECC does not require automatic plug load control, but may adopt requirements in the near future. In the 2010 and later versions of the 90.1 energy standard, at least 50% of all 125 volt, 15 amp, or 20 amp receptacles must be automatically controlled in a list of spaces, including private offices, classrooms, conference rooms, and others, in some cases based on square footage. Since the 2013 version of the standard, at least 25% of circuit feeders installed for modular furniture not shown on the construction documents must be automatically controlled for future furniture installation use. Also, since the 2013 version, all controlled receptacles are required to be permanently marked to distinguish them from uncontrolled receptacles. Compliance options include scheduling with a local override of no more than 5,000 square feet or 1 floor, occupancy sensing with 20 or 30-minute time delay depending on the version of the standard, or an automatic signal from another system such as an alarm system. California requires a mix of controlled and uncontrolled 127 volt receptacles be provided in private and open offices, office kitchenettes, and other spaces. For each uncontrolled receptacle, there must be a controlled receptacle within 6 feet. Duplex units with 1 controlled and 1 uncontrolled receptacle comply. Additionally, for open offices, at least 1 controlled receptacle must be provided per workstation. Electric circuits feeding controlled receptacles must be equipped with permanently installed automatic shutoff controls operating using occupancy sensing or scheduling. Countdown timers do not comply. All controlled receptacles are required to be permanently marked to distinguish them from uncontrolled receptacles. Additionally, at least 50% of receptacles in hotel and motel guest rooms must be automatically turned off within 30 minutes of vacancy via an occupancy sensor, captive key switch, or some other form of control. Both Title 24 and the 2013 and later versions of 90.1 require that controlled receptacles be permanently marked to distinguish them from uncontrolled receptacles. Starting in 2014, the National Electrical Code specifically required the following. All non-locking type 125 volt, 15 or 20 amp receptacles that enact or are used to enact automatic removal from power for the purpose of energy management must be permanently marked with the symbol shown here. Beginning in the 2017 NEC, the word controlled was added to the symbol. As a result, controlled receptacles may be found in the field with the symbol but not the word controlled. The marking must be on the receptacle's face and visible after installation. When a duplex or quadruplex receptacle is installed that is only partially controlled, the plug or plugs that are controlled must bear the required markings. Additionally, the NEC required that automatically controlled receptacles being replaced must be replaced with equivalently controlled receptacles, unless automatic control is no longer required. Utility rebate programs recognize the energy saving potential for automatic control of plug and process loads. In 2020, rebates of various types were available from scores of programs covering much of the United States. The most commonly incentivized categories include plug load occupancy sensors, advanced power strips, vending machine controllers, computer power management software, and plug load Energy Star equipment such as computing devices and electronically commutated motor plug fans. The Better Buildings Initiative maintains a database of plug load incentives on its website. Now we're ready to look at the strategies used to control plug loads in commercial buildings. Similar to general lighting control, the main strategies are scheduling, which is based on vacancy that's predicted, and occupancy sensing based on vacancy that's detected. The third option is a signal from another system, such as a building automation or security system. Application of these strategies for lighting control is very similar to controlling receptacles, resulting in a high degree of compatibility. Scheduling is relatively simple and well suited to larger open applications with predictable occupancy, as well as loads that must remain on during business hours, such as water coolers and shared printers. With this approach, users should or shall, where certain energy codes apply, be given a means to override the shutoff for up to 2 hours via a manual switch located either in the space or on the receptacle itself. Occupancy sensing can generate high energy savings by being directly responsive to occupancy and vacancy. This approach is well suited to smaller enclosed spaces such as private offices and conference rooms, particularly where occupancy is intermittent and unpredictable. Only loads that can be turned off during business hours should be controlled. The sensor functions as its own override by providing automatic on as well as off. Depending on the type of lighting control system, these strategies could be blended within the same space to maximize energy savings while minimizing potential disruption for occupants. For example, the receptacles could be scheduled on during operating hours, after which occupancy sensor-based control would take priority. Now that we understand the strategies involved in plug load control, we can look at equipment. The core element of this type of control is the automatic receptacle. This is a receptacle that's capable of responding to a control signal or is fed by a branch circuit that is capable of responding to the signal. Each receptacle in a duplex unit can be automatically controlled or only one. For example, the top's controlled while the bottom isn't. This allows separate control of plug loads that can be turned off, for example, a computer monitor, and those that must remain on, for example, a computer's CPU. Controlled receptacle circuits can be switched using one of three methods: controllable circuit breaker panel board, lighting control relay panel, or via a relay in a local plug load dedicated power pack, lighting control panel, or at the receptacle itself. Any power relays used must be properly rated for receptacle controls. For scheduling, the control panel or receptacle with integrated timer will feature time clock functionality and should be capable of override via switch in the space or on the receptacle itself. The control panel should be able to respond to external signals via basic connection. If the system is networked, remote programming, measuring, and monitoring via software or a web page is often enabled. Occupancy sensors are typically standalone, but may be connected as well. Although the plug loads may utilize the same occupancy sensor used to control the general lighting, plug loads should be controlled separately from the general lighting if a manual switch is used. One approach to plug load control is advanced power strips. These are power strips controlled by occupancy sensors, smartphones, or another method, and as such they're ideal for plug load control in workstations. Shown here is an 8 receptacle power strip with surge suppression and 2 uncontrolled receptacles and 6 controlled receptacles via a personal occupancy sensor, which is also shown. Portable or plug-in advanced power strips are not permanently installed, and therefore they are not compliant with energy codes, though they may be suitable for applications where the code doesn't apply, such as some retrofits. For code compliance, the advanced power strip must be permanently installed, which means hardwired to power. Plug-load signal connections may be wired or wireless. For some applications, notably existing buildings, wireless connection, typically via radio frequency, can simplify installation and reduce installed cost. These receptacles feature an integral wireless receiver and integral relay. A device such as an occupancy sensor sends wireless signals to controlled lighting, but also to the receptacle, which connects or disconnects from the branch circuit using an integral relay. This allows expanded utility from the occupancy sensor without any new wiring or changes to existing wiring, which simplifies installation. The wireless controlled receptacle may also feature integrated power metering. Let's look at 3 example configurations. First, here's a system in which an occupancy sensor and manual switch operate separate power packs dedicated either to lighting loads or controlled plug loads. Next, we have a lighting control relay panel with time clock functionality for scheduling, as well as inputs and outputs for control of lighting and receptacles via local manual switches and occupancy and light sensors. And last, we have a wireless system in which the occupancy sensor controls lighting and automatic receptacles via radio frequency wireless signals. Now that we understand the benefits of plug load control and the strategies and equipment used to implement it, we're ready to evaluate buildings for opportunities. As with every other aspect of lighting and control, there's no one-size-fits-all solution for plug load controls. When selecting the right plug load control solution, start with the loads, the building, the occupants, how the spaces are used, applicable codes and standards. Then select the right approach, scheduling or aux sensing, receptacles or power strips, networked or not, hardwired or wireless. The opportunities will depend largely on whether the building is new or existing and what level of lighting control is already available or will be installed, say as part of an LED upgrade. In a new building, for example, extending the automatic lighting control system, which is required by energy code, to then also control the plug loads can be simply accomplished. In an existing building, wireless controls and portable advanced power strips with personal occupancy sensors can be similarly simple and cost-effective. Conduct a walkthrough or review the design plans to determine those plug loads eligible for control based on user needs and how the space is or will be used. Plug loads required to operate continuously for business or safety reasons obviously should not be controlled. Identify opportunities for support, such as local utility rebates, along with their requirements. As part of the audit, meter the plug loads to be controlled to establish a baseline level of energy consumption from which we can identify good opportunities for control. For office buildings, the Department of Energy recommends the meter be suitable for the circuit type, able to accurately meter loads up to 1800 watts, able to measure and log 1 week of electrical power with a sampling interval of 30 seconds, timestamp each data point, and offer download of stored data. Department of Energy also recommends you install any software needed to configure the meter and analyze the data produced by it. Set up the meter to measure at a sampling interval of 30 seconds if that's possible, up to 15 minutes. Power down and unplug the device, plug it into the meter, plug the meter in the device, and power on the device. Meter all day, every day for at least 1 work week, longer if possible, to generate more accurate usage patterns. Download the meter data for analysis and to calculate average load during business and non-business hours. Note that some control systems incorporate customizable software-based energy metering, which automatically measures plug load energy consumption, displays it on an app, and shares it as needed. Based on this energy use data, you can identify opportunities to reduce energy consumption via scheduling, aux sensing, or a combination of the two, or a signal from another building system. Along with application characteristics, these strategies will reveal what equipment you'll need for the project. As with any energy efficiency control system or strategy, they are most effective when used properly. Plug load controls rely on users plugging the right devices into the controlled and uncontrolled receptacles. Educate the users how the plug load control in their space functions, how to distinguish a controlled receptacle from an uncontrolled receptacle, and what devices should be plugged into each. A best practice is to provide a simple leave behind informational sheet that covers how to effectively use plug load controls. So now we can wrap this up. Plug loads are a substantial and growing part of commercial building energy consumption, and many of these loads can be automatically controlled to save energy as an extension of general lighting control, either as a target of opportunity or to comply with the latest energy codes. There are many different types of strategies, equipment, communication methods, and levels of capabilities to match different types of applications. And to find the best approach for your project, be sure to evaluate the load and application. And now a quick word about the authors of this webinar, the Lighting Controls Association. We're the voice of the lighting controls industry, made up of manufacturers. It's a council of NEMA. It's dedicated to educating the public about lighting controls. Most of our activity takes place at our website, lightingcontrolsassociation.org, and affiliated social media such as LinkedIn. Each month we publish products, articles, projects, and so on. We also have a very robust online distance education program called Education Express, which is free. You sign up, it takes less than a minute, and then you can access more than 20 courses on topics ranging from occupancy sensors to designing lighting control systems. One of our new courses is on automatic plug load controls. So if you would like to get education credit for this webinar, you can go to Education Express, sign in, and take the quiz at the end of the course, and then you will qualify for education credit. And that concludes this webinar. Thank you so much for attending. It was a pleasure to share this information with you about a topic that is growing in importance in lighting and building control. I hope you found the information useful, and thanks again.